Dear students, in this lecture you are going to learn the derivatives of hyperbolic functions. In the previous lecture we have seen the derivatives of trigonometric functions as well as inverse trigonometric functions. Now in this, so the derivatives of hyperbolic and inverse hyperbolic also. As we know, the functions like hyperbolic functions, again there are six functions will be there, like a sine hx, cos hx, tan hx, cot hx, secant hx and cosecant hx, and their inverses. So now we will see their derivatives. Now for first one, the derivative of, like it is d by dx of sine hx, not sine of hx, it is sine hx. So the derivative of sine hx is cos hx. So we'll see the proof of this. So the derivative of sine x is how it will be cos h. See, as we know the definition of sine hx, so this is the combination of exponential functions, right? So the derivative of sine hx, and you know the definition of sine hx, that is e power x minus e to the power of minus x whole by 2. So this is the definition of sine hx. Now also it is e power x and e power minus x. Already we know the derivative of e power x and e power minus x. So here 1 by 2 is a constant. So that this is the derivative of, separate, it is like a derivative of e power x minus derivative of e power minus x, right? Now, so this is 1 by 2 times of, so derivative of e power x is e power x minus derivative of e power minus x is minus e power minus x. Derivative of e power minus x is e power minus x into derivative of minus x is minus 1. So finally this is 1 by 2 into e power x plus e to the power of minus x. And we know the derivative e power x plus e power minus x by 2. So this is the definition of cos hx. So therefore the derivative of sin hx is cos hx, right? So similarly you can evaluate the derivative of cos hx. So d by dx of cos hx మీరు చేసేయండి. So this is equals to sin hx వస్తుంది. Okay, now you can use the definition of cos hx, that is e power x plus e power minus x by 2, దాని డెరివేటివ్ అండి, and e power x minus e power minus x by 2 వస్తుంది మనకి. Okay, now so next tan x చూద్దాం మళ్ళీ. Number 3, the derivative of tan hx. So d by dx of tan hx, tan hx, not tan of hx, it is tan hx. So the answer is secant h square x. The derivative of tan hx is secant h square x. Now, so d by dx of tan hx. Now, so already we have two derivatives, sine and cos, and you know how to write this tan hx. Tan can be written as sine by cos, right? Again, so but the trigonometric ratios and hyperbolic functions are quite different. They are not same. Okay, even the definition also different. So the definition of sin hx is like e power x minus e power minus x by 2, whereas in the trigonometric ratio they are defined over circular functions. They are on circle based on a right angle triangle, like opposite side divided by hypotenuse for sin x. Here sin hx is different. Now here d by dx sin tan can be written as a sin h of x divided by cos h x. It is u by v form. So u by v, already we know quotient rule, right? So apply the quotient rule for the derivative, that is cos hx into d by dx of sin hx, right, minus sin hx into derivative of cos hx. Okay, now so which is equals to, so divided by then cos h square x or cos hx whole square, that is this. Now so cos hx into derivative of sin hx is already we know, that is cos hx minus sin hx into, now derivative of cos hx is sin hx divided by cos h square x, now which is equals to cos hx into cos hx is, so this is cos h square x minus sin h square x divided by cos h square x. So cos h square x minus sin h square x is 1 divided by cos h square x. Okay, so whereas in trigonometry that cos square theta plus sin square theta is 1, here in a hyperbolic function cos h square x minus sin h square x is 1. So this is a basic identity in hyperbolic functions. So 1 by cos h square x means it is secant h square x. So the derivative of tan hx is secant h square x. And next, so based on this you can evaluate the derivative of derivative of cot hx. Derivative of cot hx is minus cosecant h square x. So derivative of cot hx is minus cosecant h square x. So next, the fifth one, derivative of, that is secant hx. So derivative of secant hx is minus secant hx into tan hx. Similar undi, but ikkada negative undi. Derivative of secant x is different. It is secant x into tan x. But secant hx ainappudu emutundi minus secant hx into tan hx. Okay, now so you can use the derivative for this. So using quotient rule or reciprocal rule also no problem. Since already we know 1 by cos hx, right? So we can write this as a d by dx of 1 by cos hx. Similar rule kada, secant can be written as, so it is these two are the reciprocals to each other. Now, so we are 1 by u form. We have a d by dx of 1 by u, right? 1 by u means 1 minus 1 by u square into derivative of u. So we can express this as minus 1 divided by cos h square x into d by dx of cos hx. Right? Now, so this is a minus 1 divided by cos h square x into derivative of cos hx is sin hx. Now, so this cos h square can be written as cos hx into cos hx, like it is a minus 1 by cos hx into, so sin hx by sin hx, sorry, cos hx. Now, so minus 1 by cos is nothing but secant h, and sin by cos is tan hx. So the derivative d by dx of secant hx is this one, right? Now, so by using this, similarly you can evaluate the derivative of cosecant hx. Derivative of cosecant hx is, here it is minus cosecant hx into cot hx. So we will see some examples on these hyperbolic functions derivatives. So later we will discuss about inverse hyperbolic functions. So find the derivatives of the following functions. So the first example is y equals to, for example, like it is sin h of sin x sin h of sin x is given. Now how to find the derivative of this? So this is we know the derivative of sin, right? Then here inner function is sin x, and already we know the derivative of sin x. Now so it is a composite function, means here we need to apply the derivative for this by using a chain rule, right? So the derivative of this is, now dy by dx is equals to d by dx of sin h of sin x. Okay, now first derivative of sin h emutundi cos h of, as it is, this is sin x only, into d by dx of inner function, that is sin x. So finally this is cos h of sin x into, now derivative of sin x is cos x. So therefore this is a cos x into cos h of sin x. Now so y is equals to, now say this is a tan h of e power x, tan h of e power x. So means dy by dx is equals to, now the derivative of tan is, tan h is secant h square of e power x into derivative of e power x, derivative of e power x. So derivative of e power x is e power x, and so finally we can write it as e power x into secant h square of e power x. So like that. So next, third one, y equals to, now secant h of sin of cos of e పవర్ ఎక్స్ ఉందనుకున్నాం. ఫంక్షన్ చూసి భయపడాల్సిన అవసరం లేదు, ఒక్కొక్క దాన్ని కట్ చేసుకుంటాను. ఫస్ట్ డెరివేటివ్ దీనికి ఇంటూ డెరివేటివ్ ఆఫ్ దిస్ ఇంటూ డెరివేటివ్ ఆఫ్ దిస్, ఫైనల్లీ డెరివేటివ్ ఆఫ్ దిస్ ఈజ్ ద ఫైనల్. Okay, now so dy by dx is equals to, now so derivative of secant h అవుతుంది, secant of as it is ఉంటుంది, let it be the secant of like this, so that it is secant h derivative is secant h x into, minus secant h x into tan x కదా, that is sin of cos of e power x into tan h of sin of cos of e power x. So like this. Now so which is equals to into derivative రాలి కదా, so into derivative of sin of cos of e power x. Okay, so directly here I am writing the answer for this. అసలు డెరివేటివ్ చేసి మళ్ళీ దీని డెరివేటివ్ చేసి ఇంటూ డెరివేటివ్ ఆఫ్ e power x రాలి. So this is minus secant h of sin of cos of e power x into tan h of sin of cos of e power x into derivative of sin అవుతుంది cos of e power x into derivative of cos is minus sin of e power x into derivative of e power x is e power x. So may try and it. Okay, now so how to, so this is the answer for this problem. Now so this is the product secant h to tan h into cos of minus sin. So next, fourth problem. So y equals to, then so this is given log of cos h to x. So find the derivative of this function cos h to x. Now dy by dx is equals to, now first derivative of log of x ఉన్నప్పుడు 1 by x కదా, so this is 1 divided by this is cos h to x into derivative of cos. Now so this is 1 by cos h to x into derivative of cos is sin h to x into derivative of మళ్ళీ ఇన్నర్ ఫంక్షన్ కదా, సో దిస్ ఈజ్ d by dx ఆఫ్ 2x. ఇంతకుముందు ప్రాబ్లం కూడా అలానే ఒక్కొక్కటి కట్ చేసుకుంటారండి. నా సో ఫైనల్లీ దిస్ ఈజ్ sin by cos, సో ఇట్ ఈస్ tan h to x into derivative of 2x is 2, so the derivative of this is 2 into tan h of 2x. So derivative of log of cos h to x is, so 2 into tan h of 2x. So fifth one, y equals to, ఇది ట్రై చేయండి, log of tan 5x. So ఇక్కడ hyperbolic function కాదు, tan of 5x, only tan function is given. Now so how to evaluate this? This is dy by dx is equals to, now so log derivative is 1 by అక్కడ ఏ ఫంక్షన్తో చేసేయండి. సో tan of 5x ఇంటూ d by dx of tan 5x అవుతుంది. d by dx of tan 5x. Now so 1 divided by tan 5x into derivative of tan x is secant square x, but instead of x 5x is there, so 5x into మళ్ళీ ఇన్నర్ ఫంక్షన్ ఏంది అక్కడ 5x is there, so this is d by dx of 5x. Now so secant square 5x by tan 5x into derivative of x, derivative of 5x is 5. So this is the derivative, or you can simplify also. So secant square can be written as 1 by cos square and tan can be written as sin by cos. So before that so 5 into secant square 5x by so tan 5x వచ్చేసింది. So if possible you can so simplify also, no problem. So simplify that, so which is equals to 5 into tan secant square can be written as 1 by cos square, right, cos square 5x into divided by tan 5x is there, so tan 5x and sin by cos, so reverse lo avutundi, so whole divided by sin 5x by cos 5x. One cos will be gets cancelled, right. Now so finally this is 5 divided by reverse అయితే అవుతుందా, so it is sin 5x into cos 5x అవుతుంది, sin 5x into cos 5x. So it is like a sin a into cos a కదా. So if you multiply and divide with 2, multiply and divide with 2, then so this is a 10 divided by ఏమవుతుంది 2 sin a cos a, so that is sin of 2a, 2 into 5x. So finally this is a 10 into sin of 1 by sin of 10x, అంటే అవుతుంది cosecant of 10x we can express. ఇక్కడితో కంప్లీట్ అయింది. ఇఫ్ పాసిబుల్ యూ కెన్ సింప్లిఫై హియర్ ఆల్సో. సో ఫైనల్లీ దిస్ ఈజ్ 10 into cosecant of 10x. Then sixth problem, y equals to, now it is tan inverse of tan h of x by 2 in. So hyperbolic function and this is trigonometric function. Okay, so you know how to apply the derivative for this. Now so dy by dx is equals to, now derivative of tan inverse is 1 by 1 plus x square, right, 1 plus x square plus ఉంటుంది కదా. Now so we can express it as tan h square of x by 2 into d by dx of tan hx by 2, tan hx by 2. So this is, so 1 divided by 1 plus tan h square x by 2 into derivative of tan is, that is so it is secant h square x by 2 into only the inner function is d by dx of x by 2. So d by dx of x by 2 is 1 by 2. So finally this is secant h square x by 2 divided by x by 2 2, so it is 2 into 1 plus tan h square x by 2. So this is the derivative of tan inverse of tan h of x by 2. The next derivatives of inverse hyperbolic functions. So we need to show the derivatives of inverse hyperbolic functions. So as we seen the proofs for derivatives of inverse trigonometric functions in a similar manner, so you can show the derivatives of inverse hyperbolic functions. So here I am writing only the formula directly. So the first thing is the derivative d by dx of sin h inverse, notation is kada, sin h inverse of x is 1 by square root of 1 plus x square. As you know the domain x is belongs to R. Now second one, the derivative d by dx of cos h inverse of x, this is 1 divided by root of x square minus 1. Here x is from 1 to infinity. Next, the derivative of tan h inverse x. Tan h inverse of x. This is 1 by 1 minus x square. Here x is belongs to minus 1 to 1. And fourth, the derivative of cot h inverse. So derivative of tan h inverse x and cot h inverse x notations are same, 1 by 1 minus x square. But so this is valid when x is belongs to other than this, like it is a minus infinity to minus 1 union 1 to infinity. So cot h inverse x is defined over this only, and tan h inverse x is it. But output will be the same for both tan h inverse and cot h inverse. And now fifth one, derivative of secant h inverse x. That is 1 divided by, I think it is minus 1 divided by mod x into root of 1 plus x square. Here x is between 0 and 1. Now dy dx of cosecant h inverse of x. Now it is also same, but the domain is different. So it is minus 1 divided by mod x into root of 1 plus x square, and here x is belongs to all real numbers except 0. This is, see, I think it is minus. So secant h inverse of x is minus 1 by mod x into root of 1 minus x square. This is minus 1 by mod x into root of 1 plus x square. Okay. Now see, we have seen some formulas in hyperbolic functions, inverse hyperbolic functions. Means the relation between inverse hyperbolic functions and logarithmic functions, right? So they are, number one, sin h inverse of x. Sin h inverse of x, that can be written as a logarithm of x plus square root of 1 plus x square. Now the second one is cos h inverse of x. సో వీటిని డెరివేటివ్ చేసినా కానీ మనకి ఇదే వాల్యూ వచ్చేస్తుంది, లైక్ లాగ్ ఆఫ్ ఎఫ్ ఆఫ్ ఎక్స్ లాగా ఉంది కదా. నా ద నెక్స్ట్ థింగ్ ఈజ్ లాగ్ ఆఫ్ దిస్ ఈజ్ ఎక్స్ ప్లస్ రూట్ ఆఫ్ ఎక్స్ స్క్వేర్ మైనస్ 1. అండ్ థర్డ్ వన్ టాన్ హెచ్ ఇన్వర్స్ ఆఫ్ ఎక్స్. ఇవన్నీ మనం హైపర్బాలిక్ ఫంక్షన్స్లో ప్రూవ్ చేసాం. 1 by 2 into the logarithm of 1 plus x divided by 1 minus x. Here 1 minus x square value is greater than 0, whereas in this compulsory x is greater than or equals to 1, then only it is possible, right? Otherwise square root of negative number is not possible, so therefore x square is strictly greater than 1. Less than 1 ki possible kaadu. Let us see some examples on inverse hyperbolic functions regarding the derivatives. Number one, here y equals to sin h inverse of, let it be, it is e power x is e power x. Now sin h inverse of e power x. Now so you know the derivative of sin h inverse of x, that is 1 by square root of 1 plus x square, right? So similarly apply the derivative for this. Dy by dx is equals to derivative of sin h inverse 1 divided by root of 1 plus x square. Instead of x, e power x is there, so this is e power x whole square into derivative of e power x. Now so this is 1 by square root of 1 plus e power x whole square, means it is e power 2x into derivative of e power x is e power x 1. So this is finally e to the power of x divided by square root of 1 plus e to the power of 2x. Now second one, y equals to some, it is a cos h inverse of let it be, it is a sin x అనుకున్నాం. Now the derivative of cos h inverse of sin x. So before that we need to know cos h inverse derivative and sin x, and this is a chain rule, right? Now the derivative of this dy by dx is, now cos h inverse of x derivative is 1 by root of x square minus 1, right? So 1 divided by square root of x square, so sin square, so it is sin square x minus 1 into d by dx of sin x. So d by dx of sin x is cos x. So cos x divided by root of sin square x minus 1. So this is not cos square x, because 1 minus sin square x equal cos square x. So let it be, leave it. Now, so y equals to like it is a tan h inverse of x square, tan h inverse of x square. So the derivative is, derivative dy by dx is equals to, now so this is 1 divided by 1 minus x square whole square over into d by dx of x square. Derivative of x square is 2x. So finally this is 2x divided by 1 minus x to the power of 4. Next, fourth one, y equals to sin h inverse of let it be this secant x, sin h inverse of secant x. Now the dy by dx is, derivative of secant h inverse x is sin, so it is sin. So derivative of sin h inverse is, now it is 1 by root of 1 plus x square, right? Now so this is 1 divided by root of 1 plus, so 1 plus secant square x into d by dx of secant x. Now it is 1 divided by root of 1 plus secant square x into derivative of secant x is secant x into tan x. Fifth one, y equals to cot h inverse of, so it is cos theta with respect to theta. So you need to find the derivative of this with respect to theta. Then what will happen? So here you need to find the dy by theta. Here the question is dy by theta, independent variable changes. So this is dy by d theta, which is equals to cot h inverse derivative is, so 1 divided by 1 minus x square, right? So x square is nothing but cos square theta into derivative of cos theta. Now so this is 1 by 1 minus cos square theta, that can be written as sin square theta into, so derivative of cos theta is minus sin theta. So finally this is sin theta by sin square theta, that is minus 1 divided by sin theta, so which is equals to minus cosecant theta, right? So then sixth one, so y equals to, it is tan h inverse of x square into cos x. Now so interesting problem. Now so it is dy by dx is equals to, now first derivative of tan h inverse. Derivative of tan h inverse is, so this is 1 divided by 1 minus x square. X square is x square into cos x whole square into derivative of only inner function kada, x square into cos x. So inner function ela unchoni, inner function is here algebraic function and trigonometric function is there. So here we need to apply u into v. Now so this is 1 divided by, so 1 minus x square whole square is x to the power of 4 into cos square x into derivative of this, So here we need to apply x square into d by dx of cos x plus cos x into d by dx of x square. Now, so this is 1 divided by 1 minus x to the power of 4 into cos square x into the derivative of your x square into cos x derivative is, so this is a minus sin x plus cos x into x square derivative is 2 into x to the power of 2 minus 1, so this is 2x. So finally this is a minus x square into sin x plus 2x into cos x whole divided by 1 minus x to the power of 4 into cos square x. So this is the derivative of the given function. So dear students, I hope you understand the derivatives of hyperbolic and inverse hyperbolic functions and some problems. So do the problems in exercise which are related to these things. Thank you.